Let's look at how to find the circumcenter of a triangle using our algebraic principles of slope and midpoint. So this is more coordinate geometry, and we're going to use those formulas to figure out where the circumcenter is based off these three coordinates that make a triangle. So you and two friends want to meet at a central location. Anytime you see something like that, think about you and your friends being the vertices of the triangle, and you're going to use those as the coordinates. And if you want to be equally distant from three things, you're going to use the circumcenter. So here we have the coordinates of these three cities, A, B, and C, and we want to find the coordinates of the central location. So the first thing we're going to need to do is, since we want to find the circumcenter, we need the perpendicular bisectors. And for perpendicular bisectors, there's two really important pieces here. To be perpendicular, that's going to use the slope formula. And to be a bisector, that's going to need the midpoint. So to find the circumcenter, we're going to need the midpoint and a perpendicular slope from each side. So let's focus one side at a time. So first, if we're working with side AB, I'm going to need both the midpoint and the perpendicular slope to write the equation of the perpendicular bisector. So for AB, first finding the midpoint, that formula says to add together the x values and divide by 2, and do the same thing to the y values. So from that, the midpoint of AB is 5, 5. So we can see that point right here. We can label it on this picture if it'll help. So now I have the midpoint. The next thing I need is the perpendicular slope. So the slope of AB, the slope formula is y2 minus y1 over x2 minus x1. So it's negative 10 over 10, or negative 1. So that's the slope of AB. To be a perpendicular bisector, I need to use the opposite reciprocal slope. So if this is negative 1 over 1, my opposite reciprocal slope will be positive 1 over 1. So that one has a slope of 1. So to write the equation of the line, I use y equals mx plus b, and I plug in the things that I know. So the x and y value, those are coming from the midpoint here. That's what I'm going to plug in for x and y. And then I'm going to use my slope I just found of positive 1, that perpendicular slope. So I'm going to plug these things in to find my y-intercept. So 1 times 5 is 5. If I subtract 5 from both sides, I get that the y-intercept is 0. So the equation of this line equals y equals 1x plus 0, or just y equals x. So here is that perpendicular bisector equation. So now I need to find another equation. So you can find all three, or you can find just 2 of them and use that to figure out where the circumcenter would be using a system of equations. So let's find another side, and you can choose either side. So if I do AC for my other side, I just chose a random one. To find the midpoint of AC is the first thing I'm going to do. So I add together those x values and divide by 2. Do the same thing with the y values. And I find that my midpoint is 7, 10. So that would be the coordinate of this point E right here. I can label it if I'd like. So that's one part. The next part is the slope. I want to be perpendicular, so I need to find the slope of the existing line and then do the opposite reciprocal. So y2 minus y1 over x2 minus x1. So that is 0 over 14. So that's a zero slope. Zero slopes are horizontal. To be perpendicular to a horizontal line, that's going to be vertical or an undefined slope. And so whenever we have an undefined line that's going straight up and down, the axis it's going to cross is going to be the x-axis. So since it doesn't have a number slope like 0 or 1, we can't write a y equals line. So this is an x equals line. And to write the equation, we use the x value of the point that we're going to go through. So the x value of this midpoint is 7. So the equation of this perpendicular bisector is x equals 7. So that's this vertical line that goes through that midpoint. So to find the circumcenter, what we do is we take the two equations that we find. So here are my two equations. I have y equals x and x equals 7. So this is a system, and the way I can solve this system is through a process called substitution. And with substitution, it's a method for solving systems. In this system, I know that x equals 7, so I'm going to put 7 where the x is in the other equation, which gives me an equation of y equals 7. So just by using substitution, I've already found my y value. So if x equals 7 and y equals 7, the coordinate of the circumcenter is 7, 7. So this is the coordinate of the point that is equidistant from the three vertices of the triangle. The last thing we're going to do is to verify that this is the central location, which means that it should have the same length to each point. So I'm going to use the distance formula. And the distance formula is the square root of a squared plus b squared, where a is how far it is between your x values and b is how far it is between your y values. So what I'm going to do is I'm going to take this point, 7, 7, and I need to look at how far it is from A, B, and C. So for each one, I use the circumcenter point, 7, 7, and then I'm going to use the coordinates of those points. So let's get those written down real quick. So the coordinate of A was 0, 10, the coordinate of B was 10, 0, and the coordinate of C was 14, 10. So to verify that this is the central point and that it's equidistant, I'm going to look at the lengths between those points. So from the circumcenter to point A, I look at how many units are between the x values. So between 7 and 0, that's 7 units. And between the y values. So between 7 and 10, that is 3 units. These are my A and B for my distance formula. So this is going to be the square root of 7 squared plus 3 squared. And that's going to give me 49 plus 9, which is 58. So I have the square root of 58. Now let's see if the distance from the circumcenter to point B is the same. So I'll look at how many units are between my x values. From 7 to 10, that's 3 units. And my y values. From 7 to 0, that's 7 units. So plug this in. 3 is my A value. 7 is my B value. And 7 squared plus 3 squared, it's going to give me the square root of 58. I can skip that middle step since I've already worked it out over here. So far I've got two distances that are the same. Got one more to look at. So I look again at those distance between the x values and the y values. Plug those into the distance formula. And again, I get the square root of 58.